Thanks so much. Hey everyone, how's it going? Oh, applause. Feels very special. Just to quickly know who I'm speaking with, can I just get a quick show of hands? Who? Thank you, Andrew. Noted. Check. Okay. Who's here from state or local government? Anyone? So private sector primarily, vendors, people who are doing software development in the space. Great. Do many of you work with state and local government customers or in the public sector? One. Okay, cool. So you might wonder then why I am here speaking with you. So I'm the leader over Health and Human Services Analytics at Amazon Web Services. I joined this team from the state of California, where I was the chief data officer overseeing social services, all things research, automation, data for the whole state, for all things TANF, SNAP, childcare, child welfare, licensing, et cetera, all through COVID. And before that, I was the TANF director, before that, a policy researcher. Now, as a policy researcher at Mathematica, one of the things that I learned was how difficult it is to get from policy, good policy, understanding what it is you're trying to do to serve your constituents, to automation, to actual implementation on the ground of that policy. And one of the things that we learned in that space that made it so challenging was often the technology. It was data systems. It was the inability for partners and systems that needed to talk to each other to, in fact, do that. We have a lot of antiquated administrative systems in the government space in health and human services. We have a lot of things that were designed 15, 10, 20 years ago. And so what you have now is this leg. You have the challenges of sort of former data practices infiltrating today's implementation space. And so as I was in that world of being the chief data officer and trying to figure out how to help 14 to 20 million people a month actually engage with the government more effectively, I figured out very quickly that I needed to learn a whole lot more about technology and what vendors in the space were doing and how I was going to have my needs met in a different way. Then the next thing that you find out when you start to have that conversation and you go down that path is that your data systems are often designed to do something other than what you are actually asking it to do today. And so as you update practices, as you update your policy, as you update what it is that you think it is your role to do in government when you're engaging constituents and others, your systems have to follow. And so oftentimes these things were designed, they weren't well documented, they're around processes and administration, not around outcomes. And so the deeper I got into that space, the more I learned about what's happening in modern architecture, what's happening in modern technology, what are the services and vendors that are out there and how can they better meet my needs? And so that's really what brings me into this space and this conversation today. Now, interestingly, a lot of the things that customers are likely asking you for are the same thing that customers are asking me for in the public sector. And so what we see people actually talking about today is often improved user experience, better use of data, increasing agility, and by the way, all of that for a lower cost. And so that's really what we're in the business of doing at this point, is coaching people through these life cycle changes. I call what I do sort of two parallel tracks. I spend a lot of time talking about data modernization, and then sort of an equal amount of time speaking about digital transformation. So there's sort of two parallel pieces that often have to come into play here if you're actually going to transform what it is that you're doing when you're engaging with your customers. So I spent a lot of my time talking about the data lifecycle. Now, theoretically, you should see this kind of lifecycle reflected in architecture that's related to software, where you're thinking about data analytics, inference, curation, but oftentimes we forget to start at the beginning around capture. So this is a pretty common, basic conversation I have to have with government entities that hopefully I don't have to spend a lot of time with you on here today. More importantly for you is probably being in the space of thinking about what are the stages of the data lifecycle and how are we using modern advanced technology practices to align with these stages. And so now I think about it in terms of breaking down aspects of the data lifecycle from collection to ingestion to data lake to data prep to cataloging, and really thinking through how do we separate these things into microservices architectures? How do we make sure that as we develop agile practices and understand that things are going to change in the systems as you're designing them, that we're designing them with these cross-cutting concerns in mind? How do we make sure that I can take something from collection to ingestion, ingestion to data lake, and if I want to change the way that I'm doing ingestion, or if I want to change the way that I'm applying access controls, that it doesn't break when I change those practices, right? So that I actually have agility in the way that I'm developing. And I oftentimes can do that by putting these cross-cutting data transport, security, and compliance mechanisms in place. Now, that means that you have to have actually thought through something strategically, right? It's difficult to have something flow through lines of code or flow through practices if you haven't documented it. And so from a governance standpoint, that means you have to have theoretical underpinnings and frameworks around master data management and around security that you're then trying to apply across those various stages of the data lifecycle. And what that ends up looking like when it comes to the platform then is that you've actually taken and broken these things down into a loosely coupled or decoupled architecture with microservices applied appropriately. Pause there. Hopefully that makes a lot of sense and sort of lands. And so this is a very basic mechanism that I'll use oftentimes with state and local government customers as we're trying to navigate this landscape of how do you modernize your existing data infrastructure. And then from there, we can start to talk about what different practices across this space might look like to get to something that actually feels like a modern data platform. So in terms of health, this would be a common way that we talk about this in health and human services. So thinking about different kinds of enterprise systems, different kinds of external data sources, all coming into a shared environment where we set up an appropriately architected, loosely coupled architecture so that as these systems change, which they do on a regular basis, so that as policy changes, as the way that we think about disrupting poverty changes, maybe as the way that we think about serving researchers or physicians changes, the architecture in the middle is designed to be flexible and to be agile around those practices because we've built it in a way that makes sense and where the data applications are flowing through. And so we see these things end to end in a cycle. We want to make sure that those arrows remain two-way streets and that everything that we have at the bottom in terms of security and governance can be applied across the entire architecture up top. And so this is a way that we talk about this very commonly. Now, a third of my job is talking directly to customers and helping them understand these basics. About a third of my job is talking to our vendor and partner community. So people who are actually building the tools and pieces that we're going to plug into this architecture to make work. And the other third of my time I spend talking to internal teams at AWS. So coaching people on understanding why this modern data architecture and all of these various aspects of the data lifecycle are so critical. So hopefully some of this is resonating, right? That sort of middle third would be all of you. So spend a lot of time trying to make sure that we have the right vendors in the space to plug into those various stages of the data lifecycle. What's cool is that we're seeing growth in the government space, and increasingly we're seeing customers get hip to and smart to the fact that they shouldn't be custom building monolithic system integrated systems anymore, right? That we're actually getting to the point where they're buying integrated services, where they actually are working with us to think through these loosely decoupled architectures, and we need to make sure that we have people in the space that can serve those needs. Now, to you, hopefully, the ways that this makes sense is thinking about how are you sanitizing your inputs on the front end of that data ingestion? How are you making sure that things like those master data management strategies and security practices and those data policies are flowing through your APIs, and so that when policies change and that those policies are driven throughout your code also change with it? How do you think about separating your compute from your data? These are probably questions that resonate a little bit more with the kind of work that you're doing, and so this is where I'm going to spend more of my time speaking today. Questions about this? Other questions that you don't see here that you'd be interested in hearing about from a data governance perspective or from a modern data architecture perspective? Yeah, thank you. It's a great question. So as I go through the next set of slides, you'll see that it's mostly developed for the commercial and private sector side. So for this audience, one of the spaces that I find myself in around this data operations readiness coaching, which is what I've sort of informally named myself, one, because I'm a sucker for a good acronym, and that is DORK. But the other is because these are not unique challenges to state and local government customers. So I work a lot with our commercial side on what we call the AWS transformation guidelines. So actually creating rubrics and frameworks and playbooks that align with these practices. None of them are unique to state and local government customers. So everything I'm saying here today, I have a counterpart on the commercial and private sector side that's also working on transformation guidelines and actually applying these various playbooks across master data management and governance and security frameworks to AWS tooling and to our private sector customers. Yeah. So similarly, you're probably hearing a lot of these same things, right? So this is now the parallel to the things I was just saying about state and local government customers. You see that customers are wanting more value from their data. the data is coming in, it's growing exponentially, it's coming in from new and different kinds of sources, right? It's increasingly diverse and it's used by a ton of people. So much like that modern health architecture that I reference back to in Health and Human Services a lot, same thing here, right? You have customers asking, what are you doing with your data and how are you making sure that it's structured in a way that people can consume it and that when the different kinds of inputs change, the system doesn't break, right? That rules and attributes that we've applied across that system continue to flow through the architecture in a way that makes sense, in a way that's secure, in a way that's organized, where the data is clean, and so on and so forth. And so these are the kinds of things that we need to have effective data management strategies to reflect, right? The data has to be high quality. It should be stored in a way that is purposeful and makes sense and has security layers that are applied to it that flow through the various data elements. It has to be powered sufficiently. At AWS, these two things go hand in hand. We have purpose-built storage that should be intentionally selected for the kinds of outcomes and uses that you want. And it has tied compute power to it that is specific for that kind of storage, right? Because if you've selected the right kind of storage for the end use case, then we know something about how much compute power you might want from it. And by the way, it should be decoupled from the way the ingest and transformation occurred, right? So thinking back to the stage of the data lifecycle that we talk about in state and local government, same thing for you here in this room. So making sure that these things are purposeful and that they're tied together with the right kinds of outcomes in mind, right? So you want a different kind of service if you have regular SQL queries than if you have something that's a batch report that you run once a month and you might want to use something serverless on a big data format for it, right? Very different kinds of architecture, different kinds of purpose-built storage, different kinds of compute that we've tied to it in our hardware to apply to those use cases. And the data should have regular points of check for accuracy. And then you have to be thinking about who are your consumers? Are you federating the data? Is it centralized? How are you applying those rules and attributes across the landscape? And then you can have a modern data architecture that reflects those strategies, right? So once you've defined and thought through what those purposeful use cases are, working backwards from the outcome, working backwards into an architecture that makes sense, working backwards into storage and transformation mechanisms that align with those use cases, then you can start to look at modern data architecture characteristics that align with that, right? So in AWS in the cloud, we think about this in terms of durability and availability. So making sure that you have build practices that have your data distributed across the right kinds of availability zones and regions so that you have fail safes and resilience. Security, so that we're protecting the data both at rest and when it's moving, and that it's layered. You have fine-grained access control. So we used to talk about this in terms of like rules-based application and roles-based applications of security. Now we have tools that allow you to go right down to the row, the column, the cell, the attribute of the data, the attribute of the user. And that's what we're talking about when it comes to those loosely decoupled architectures and making sure that as you think about those data transport and security layers that are applied between each of those stages of the data lifecycle, when you change the attributes that you're assigning to individuals or to data, that should flow through your code. That should flow through that data architecture across those different stages and be applied. And we have AI/ML tools that do that. Same thing with object level controls and making sure that the way that you have production and test environments set up so that things are graduating across them, you can set up data lake layers and you can set up consumption layers within those data and purpose-built data storage to have the right levels of control for the right kinds of users. Flexibility. Storing data in one platform in a data lake allows you to then have the provenance, have the originating data, have the unstructured, structured, right, data in its original format, and then you only are reaching it and grabbing it when you have purposeful uses for it, right? So you can run things right on top of it. You have flexibility. You can put things in inexpensive storage when you don't use them frequently, but you want to maintain them for some other purpose, or you can move them up into layers where they can be consumed more regularly. Operational data storage, that reflects what I was just saying. So you have this flexibility where the don't always have to live in the most expensive kind of fancy storage in some kind of end state if you don't always need it in that end state, right? You have that ability to deliver against different kinds of operational data storage based on your needs. And you can automate pretty much all of it at this point, right? So we have AI/ML that work across all of those data transport and security functions that will allow you to have triggers that move across those systems and are applied equally. And once it is in cool purpose-built data storage and it's nice and cleaned and transformed into formats you want, we do have AI/ML tools that can run on top of it for prediction and analytics. But I think people lose sight sometimes of what AI/ML means today in the cloud. And there are lots of cool automation techniques that you can use that are leveraging ML to actually help you to have a well-architected framework against this modern data strategy. Yeah, seeing some head nods. Sorry, I'm just trying to read the room. I know I speak very quickly. I get excited about these things, but helpful in terms of where we're headed here. Does this make sense? Okay, cool. Okay. Yeah, sure.
When you say the data security, when you compare to the government and non-government, yeah.
So before Randy responds real quick, let me introduce Randy. He is your solution architect here dedicated to the state of Oregon. Yeah.
So you're really looking at a certain level of data classification. You as a customer will still have to make sure that's the plan because it's high, never really a question of that. But we would always drive customers to use commercial cloud when they can, just because of the availability and cost a little bit more. But really what you're talking about when you talk data classification is most government workloads are compliant with cloud. There's a few regulations that we need to apply. CJIS and FedRAMP 5 is the ones I deal with, and then ITAR or web.
That's right. Thank you. Sorry. And so, yeah, real quick, let me just, so for folks that are remote, they couldn't hear the answer to that. So in terms of the levels of compliance across our different cloud environments, our commercial sector environments are actually good up to FedRAMP moderate standards. And then when you need FedRAMP high or CJIS standards, you need to be in a gov cloud environment. And that has to do with other security layers that are wrapped around the actual infrastructure and hardware on our end itself and what you can do within those environments. The next question in the room was about the 11 nines of durability.
That's the durability. Your data.
4 nines. Yeah, so we'll get, if we have time, depending on how quickly I really go through this, the 11 nines has to do with the durability. That is, how likely is that data to be there when you go back to query it and ask for it again? And that is very, very durable. And so we have multiple availability zones that work across multiple regions and then multiple regions that work across the US and the world to ensure that your data is always available to you and that it's resiliently resting so that no matter what's happening, it's durable, right? It's incredibly rare, said another way, that you would ever lose a point of data when it's stored in one of our systems. Sure. So FedRAMP has to do with federal compliance standards around how PII and PHI, so that's personally identifiable information and personal health information data, can be stored. There's also versions of that for tax data, for justice data. And so we have different layers that we've built into the AWS environment to be compliant with those different standards. And we have programs to help software ISV vendors and partners to achieve those same levels depending on who your customer is. So we actually have defined programs that are templated out to help you achieve FedRAMP or CJIS or NIST or other standards that exist in that government space, depending on who your customers are. Good questions. Okay. So then moving forward in terms of what that modern data strategy would look like in action, this is a very repeatable pattern. So at this point in time, we've actually built out so many of these environments that we understand quite a bit about the do's and don'ts, the best practices of executing against that modern data strategy. So taking those core pillars that we just discussed and actually applying them, it looks something like this, right? You have data sources that come in, go into a data lake that is cataloged and governed using those master data management and governance strategies. And that allows you to then share that data across various databases and analytic tools and apply machine learning so that different kinds of people through different kinds of applications and devices can consume and contribute back into that data environment, right? So I always think about this like a life cycle. I always want to make sure that we're kind of closing the loop, right? You should always have an intended outcome and purpose that you're working backwards from architecturally to make sure that you've set up an environment that allows for that data to flow through to the right kinds of consumers for the right kinds of reasons and allow them to put data back into that system in a meaningful way. And so there are a few ways that we put data to work in terms of actually applying that. So we think about first scalable data lakes. I'm sure you're sick of hearing about data lakes at this point. I always joke and talk about them as being data swamps oftentimes because sometimes they're not constructed correctly, right? So a data lake can very quickly become a data swamp. That is, you've hydrated all this data into a shared environment. But if you didn't do it with purpose and intention, if you didn't think about what your outcomes were, if you didn't actually structure that data and let it stay in kind of its originating form, you may very well end up with data that's not very useful. And so we often think about scalable data lakes in terms of making sure that that originating data is coming in its original form, right? So structured or unstructured. We do have standards-based consumption in there, but it can literally live in its existence, like it's an original format, which is really important and helpful. And so decoupling the concepts of ETL, which people still talk about, is pretty important. So moving forward, we no longer really talk about ETL as one process, right? It's not extract, transform, and load. Oftentimes we're extracting, we're loading into a scalable data lake, we're letting it rest and live there until we have something to do with it. And then we're talking about transformation. Then we're talking about applying these standards. Then we're talking about moving that data into various kinds of purpose-built storage that has the right kind of performance and access aligned with it. Then we want to use serverless wherever we can to make sure that we're keeping compute costs low and that we're aligning our practices with the consumption. So in government, for example, we have a lot of reports that get run quarterly or monthly or annually. And so there's no reason why you would want to be transforming that data and putting it into very expensive storage that's highly formatted so that you can run a query against it once a month, right? Those are the kinds of things that you can do in serverless environments and that will cost much less money and don't waste compute power and people's time if you don't actually need near real-time access to that data for purposes of analysis, right? And so again, always working backwards from that content and from that consumer to make sure it makes sense. Having unified data access, security, and governance. So along with the scalable data lake platforms, we have templates and mechanisms that will run over your data and will actually map it for you. They will look at it and you can apply different governance standards based on the attributes, machine learning practices. So again, the built-in AI applies back across all of the various aspects of the data lifecycle and the various transport and security mechanisms in between. So we'll dive deep into each one of these now, but we have maybe only 10, 15 minutes left. So is there any of this that you want to make sure we spend extra time on? All right, I'll just buzz through here. Anything you want to add yet, Randy? We're doing okay. Any other questions in the room?
Yeah, well,
Questions? Yeah, sure. Okay, so scalable data lakes. So we think about this again, broadest portfolio of analytics tools, built storage to retrieve any amount of data. S3 is really one of the most core services. It was one of the original 6 services that was released when AWS was released. This is where you get those 11 nines of durability and the 4 nines of availability. It's incredibly inexpensive. We have ML that runs on top of this S3 that is smart. And so it looks at the intelligence of how often you're actually accessing data. And you can set it up not only so that it auto scales and load balances, but also so that it automatically goes into cold storage, essentially, if it's data that you don't use a lot. So we actively decrease the cost of storage and access based on your usage of the data in near real time, which is very cool. And it has that unmatched durability, as I already mentioned. So that's the foundation really of the data lake, is this massive S3 storage buckets that are available and very easy to use. This is one of the number one thing start on in their application development journey is just moving things into S3 because it's so friendly and easy to use. And so then from there, you can actually start to apply the layers on top of it. So you're storing that data, as I've mentioned, in its own open format. It's very cost effective because of the mechanisms around ML I just said. It decouples the storage from the compute. So I think this is probably the most important part of this conversation that I'll keep going back to, is it really allows you to break down those stages of the data lifecycle and make sure that you're only applying tools when you need them, where you need them. And it gives you a choice then of analytical and ML engines to use. So as use cases change, as consumers change, as consumption changes, you can actually work backwards from that originating data to reformat and structure that data for the purposes as they make sense analytically. So purpose-built storage. So we've really spent a lot of time being responsive to customers. That's probably the number one thing AWS prides itself in, is being responsive to you. So when you have needs, when software developers, when our partners in the ecosystem have needs, they come back to us and they say, hey, yeah, your existing storage is cool. We like S3 and all, but it would be nice if you had X, Y, and Z additional features or functions. And then we go out and we figure out how to build it. And so we have an increasingly large number of purpose-built storage options for data that can sit on top of your data lake. Amazon Redshift for warehousing. We have Athena for SQL, EMR for big data processing, OpenSearch for log and search analytics, Kinesis and MSK for real-time analytics, and there are more. And then we have managed versions of these, so you can get the very basic, like Lego building blocks versions of this. You can get the managed version of this, where we'll help you set it up and make sure it's well architected and easier to consume. And then there are platform level versions of this, where we have partners that will help you to actually set up and execute code against in a platform. So lots of options here and a growing number. And again, as we've built out chip technology, as we've built out these hardware centers, there are different kinds of compute tied to different databases so that you're always aligned. You have the right kind of compute allowed for that kind of storage. Serverless and easy to use. If you listen to the talk yesterday, you heard a whole lot about this. So again, key function to make sure that you're optimizing for performance. So you're not spending money where you don't need to spend it, that you're not consuming data or putting it in places that don't regularly need it. You can trigger any one of those databases to run on top of that data lake anytime that you want to use it, and then you can have it live on, like in a Redshift environment, or you can have it spin up so that you can access it for a defined period of time, and then it shuts down. So it's a good cost-saving mechanism, and it's a nice way to trigger sequences across those data life cycles as well, right? So this is not just about storage and consumption. This is actually serverless is one of those ways that you can actually set up those various stages and make sure that they're decoupled using other AI/ML data transport services. So this can be anything from moving the data through to running the analytics to how you visualize it to where it's coming in and out of that lake formation. So again, when you think about that data lifecycle and closing the loop, these are ways that you can help that information go back in to the data lake or be pulled out of the data lake. It's a two-way street. Unified data access, security, and governance. This is easily my favorite. This is really where we've made up a ton of ground, I think, even just in the last couple of years. We have increasingly more partners out now who can help with aligning roles and attributes across different organizations and data attributes with AI/ML and making sure that truly people only have access to exactly the kinds of data and data elements and rows and columns and functions that they need. We have AI/ML that will run over data and make sure that it's identifying when you have social security numbers or phone numbers, or hey, it looks like you're about to send an email with this kind of data in it. Are you sure you really want to do that? And so there are lots of layers now that we've put in place in terms of getting down to that fine grain level of security and governance that should give folks in the development world and as well as in the consumer world confidence now that not only is the cloud secure, it's far more secure than most practices on-prem today because of the way that we've set up these various technologies to work those stages of the data lifecycle. So no one's ever going to have access to a single data element that they shouldn't have access to as long as you've written a high quality master data management strategy and then applied that through your code in these governance modules. So a lot of the same things I just said here in terms of the row level, fine grained, secure sharing, supporting the updates, everything has logging capabilities. Everything will allow you to go back and actually audit what's been done to both the data, to the lines of code, to the databases, kind of through that console environment in AWS. We have a lot of automation that will allow to make sure that you know exactly what happened to data. You always will know the life cycle of it, the provenance of it, where it was, who did it, what they did. And then we make sure that the automatic storage optimization is occurring for you. Let's put the time there. So that ML integration piece, again, we've brought that ML really into every aspect of what we've done, be it the various purpose-built data warehouses or the data transport and security layers in between. Security. So now I want to spend a minute here. So each one of these is our AI services that will allow for you to take those master data management and governance strategies and actually apply them across the various layers. So we have identity and access management controls. We have detective controls, which run across those data like guard duty and inspector. Those are those kinds of things that will allow you to do the auditing and the logging, as well as looking for certain kinds of data and flagging it for you. Infrastructure protection, so various layers and making sure that your hardening is at the right level for the different aspects of your application. Data protection itself, so that could be encryption at rest, encryption at movement. It allows you to assign keys to different people to make sure that different folks can have different levels of encryption. Incident response, love these. That allows for you to have automatic responses when things are failing, backup, security, elastic, recovery. So a lot of interesting ways that we've set up AI/ML to help with all of these various aspects of security, identity, and compliance, which helps you to give customers confidence in what you're doing. Sure. So when I think of master data management, these are all of the rules that you're taking and thinking about in terms of breaking your data down into sort of those attributes of the data and who should and shouldn't be consuming them. It's also about data standards and data dictionaries. It's a lot of documentation about understanding what's quality in data in your use case. And then making sure that those can be applied back into your environments across that data life cycle.
There's a related question on the Q&A screen.
Sure. So when it comes to that first part of the extract, transform, load concept that we sort of move away from. So I can go back to an earlier graphic, but when the data comes in at rest in a data lake, it's in its raw format, right? And so when it comes to cleaning it up or applying master data management strategies, oftentimes you're going to have to go through some kind of standardization or normalization processing. And once that's done for the use cases you've applied them to, and you're thinking about where you want that to then go rest, we would call that the clean data. So the data as it comes in might be unstructured, or it might not be formatted or normalized against a particular standard for the kind of use case that you're moving towards in terms of analytics and consumption. And so the data would be considered clean once it's gone through that transformation processing and is then resting in a form that it would actually be consumable, again, for the operational use case as it's defined. Good questions. Yeah, thanks.
The ideas and how to unify that organization culture around this concept?
Yeah, so it's a great question. And we think about this a lot of times in terms of the customers. This is Jason, by the way. He is your dedicated Oregon AWS rep. So any questions that you have after this, these two will be your guides. Unless you want to talk about going down a data journey and writing a master data management plan, then you might get to talk to me again. I'll sit around and write data dictionaries all day. So yeah, it's a good point. So we talk about this a lot at AWS in terms of people, process, and technology. And as the technology has advanced, what we've seen is the people and process tends to lag behind a little bit. So a lot of what we're talking about today, again, is that data modernization aspect of this data journey. So making sure that we're writing software programs and that we're aligning practices in updated architectures that make sense for the advanced technology that exists today. However, lots of organizations will not have processes and paradigms and workflows that align with the modern technology. So oftentimes we end up finding ourselves having conversations with both our vendor community and our partners who are developing software, as well as our customers on the consumption end, to help them to rethink processes, to understand the art of the possible, and to update their workflows and practices to align with what modern technology actually allows for you to do when it's been constructed and architected correctly. Then you have the people piece, which is the training, the adoption, the adaption, and making sure that that agility actually flows through to their practices, behavior change management. Often the hardest part of actually moving people into kinds of updated environments and applying things like governance with master data management and security layers on top of it. So if you're an organization that's still using like rules-based access control, move to attribute-based access control, takes a change in the way that you think about your very process and how it is that you want to align your processes and your people back with that technology. Thanks, Jason. Good question. So the last few slides here are about resilience, which we already spent a minute talking about due to some of the questions. So I'm going to just pause here and see if there are any additional questions in the room.
I may suggest
Yeah, so when I say master data management, it has to do with everything from how you've defined the data as you want it to be consumed through to what that standardization and normalization looks like, to how it's structured and paired with other data, and then how and who it is accessed. And so it's really an end-to-end exercise in documenting and theoretically thinking about all of the data that is in your purview from ingestion to consumption. And so that means that you have to have thought through the various levels of security and control around both access, but also what quality means in that space, what quality means today, what it meant historically, and what you anticipate it might mean in the future, and how you're going to make sure that as that data changes or the environment changes, that your practices and policies that are documented can flow through that as well. So master data management is as much about the rules that you're setting for your own organization and your own environments and your own software that will be applied to what you consider quality data, all the way through to how it's consumed and what those transformations look like. And so the master data management should be a living, breathing set of documents, policies, and processes that apply to that data across the data lifecycle that should be regularly revisited. So we spend a lot of time not only coaching people through writing the original version of their master data management strategy and setting up technology componentry that can execute against that, but then making sure that there's also dependencies avoided and that there are plans for succession and people understand who authoritatively owns some of those aspects. And so it's a lot of collaboration, as I understand it. The presentation too before me, I think in this room, was about exactly that, collaboration. So increasingly, I myself being sort of the cheerleader, the babysitter, the planner, the translator across the CIO, the CTO, the CDO, making sure that all the various people who are part of that people, process, and technology conversation are on the same page and stay on the same page around what it is an organization or a software or a vendor's approach to data is across that data lifecycle. So I didn't make it specific to human services, but I think broadly it's the same thing, right? Same practices apply. Other questions in the room? How many of you have used AWS or some of these products or think about things in terms of like the data lifecycle? Good, good, good. Does this feel like old hat? Do you feel like you're already doing this? Do you feel like there are things that would be helpful for you in the development practice and development community to actually turn around and execute against this? Right? It's all well and good in theory. It's harder when it comes to actually applying it. Does that feel right? I mean, do you feel like you've kind of got it down, or like there are things that we could be saying or doing that would be helpful to you?
One catalog follow catalog data. I would have to follow yeah, I can question and just like we in data we have a process. But how I was done, things were different. Not yes.
Yep.
So what would you say? Let's say we go in one. Yeah, process. Or like what advice would you give from day one? Measures in place to be able to be flexible in the future and adjust as business.
Yeah, it's a great question. It goes back to that conversation around agility. So increasingly making sure that you have that loosely coupled, decoupled, independent architecture is the biggest. And so even states now we're seeing come to us asking for that. And so they'll go out, they'll look for best of breed in the AWS marketplace, and they'll say, okay, take this off the shelf for my ingestion mechanism, take this off the shelf for ID resolution. I'm going to take this off the shelf for access and management control. And then they put it together in a way where it's decoupled and there's queuing that occurs in between, and where the dependencies are locked in through this AI/ML rules, where they've written down master data management and governance strategies and applied them. And then if at some point in time they no longer like the ID resolution solution they're using, they'll literally just rip it out and replace it with something new. So we see that happening a lot now, where people again are moving from that rules-based to the attribute-based. And so software vendor company comes along and says, hey, I have a better user interface that's using AI/ML for your ID resolution, and it has 80% resilience with new data. Cool, I'm gonna take out this one and put that in. But you have to have it designed in a way that that's possible, right? So increasingly it's as you're modernizing, as you're using updated technologies, as you're rethinking about the structures that flow through in terms of that purpose-built storage or consumption or analytics, is making sure that as you go back and revisit those practices, that updating your architecture allows for that kind of decoupling of those systems, right? That's also how we see a lot of the resilience working. I know there are lots of examples where things will always fail, right? So you should build for the resilience. And I think that the decoupling also helps with things like that, which people don't always consider. I know my sister's a VP at Pokemon, and they're a big AWS consumer. And they've had many, many instances where like worlds will go off in Japan or something, and suddenly you've got a couple million people hitting a site that they wouldn't have necessarily anticipated, where Elastic services automatically load balance it for them, but they've set it up in a decoupled architecture where then it can kind of queue things back out so the user experience doesn't break down and nothing else downstream in that system is impacted by it. But that only works if you set it up in that way. So I think the day one mentality is that as we increasingly understand the various stages of the data lifecycle, we have mechanisms to help you with setting up that architecture, take advantage of it. Call these guys up and say, hey, we're trying to figure out how to use ML Athena instead of something else that we used to use, or DynamoDB. We're trying to move into unstructured data away from SQL. Can you help me with a well-architected review and look back and make sure that we're migrating in an updated fashion that reflects new practices around modern data structures?